All right, time for another video here. So we're still dealing with functions. Um, we're still learning about them. There's still quite a bit of information on functions itself that we can learn about, discover. Again, these videos are not about me teaching anything. They're more my journey. But if you learn something along the way, congrats to you. If you don't, that's fine. Either way, it doesn't matter to me. I'm just sharing my journey. So let me transition this over. We left off with function examples, where we're going to do some real life examples now. So let's get started on this. If this is the first time you've seen these videos, this is W3 Schools over here on the right, VS Code on the left, which is also a text editor. This is one of the sources I'm using for, or two different sources I'm using for learning how to write C++ or learn about C++. Anyways. So real life examples. To demonstrate a practical example of using function, let's create a program that converts a value from Fahrenheit to Celsius. That is quite useful for a lot of people. So there's already programs out there like this. I do this exact same thing and stuff. So writing this program and stuff will maybe teach you how those programs work. Maybe not fully teach you how those programs work, but still teach you kind of how those programs work. I know that there's already programs like that. I've used them many times myself, either on my phone or on the computer here, because it's not a formula we have built into memory, but some people may. So let's go ahead and get this written down here. We're going to go and clear up a lot of this code here because we're not going to use most of this. Let's go ahead and get rid of all this right here because we're probably going to end up rewriting all that too. So the first thing we're going to start off with, and this is basically the starting basic point of any C+ program. Include a library, a main function. I used to write this down or type this into my text editor every single time I would do do this until I pretty much had it solidified into my memory. And now, yes, it's pretty well solidified in my memory, but I still see it every day, so it helps to keep it fresh. Anyways, let's get started with this. So the first thing here, they have a comment. I'm going to go ahead and put in here function to convert Fahrenheit, which, yes, I'm not familiar with spelling the word, so uh, maybe after doing this enough times, I'll know how to spell that word, and Celsius. Fahrenheit to Celsius. Function to convert Fahrenheit to Celsius. So the first thing we're going to do is we are going to actually create the function for that, which is a float type. Since we're dealing with decimal points that are not very long or very big, a float will work. 2 Celsius is the name we're going to give this function, which is going to be the variable. Yeah, just checking to make sure I had that spelled right. Float is going to be the type. Fahrenheit is going to be the name of the variable for float type. And then we're going to put a curly brackets in place and build the definition of the body. So in this case, we can return a value because it's not a void. We're going to put the formula in here, which is 5.0 divided by 9.0 times another set of parentheses for Fahrenheit minus 32.0, and then in that. So that's going to be the return. The formula gets put into the return. That way, all we have to do is put whatever the Fahrenheit is right here. The problem is the expression is done, and then we end up with a sum or a result of the expression that is going to end up probably getting returned. So at this point in time, I don't think it doesn't look like there's anything else. So this is the only function we're going to have besides the main, obviously. The first thing that they have here is an example, set a Fahrenheit value. So if you want to convert, you're going to have to put some sort of integer or float or double as the current temperature in Fahrenheit, and then that way you can find out what it is in Celsius. So the type is going to be float again because we're going to have a decimal point in this. F value is going to be our variable Fahrenheit value. I assume that's what that means. 98.8 is going to be our value this time around. We got another comment here, call the function with the Fahrenheit value. Again, this is going to be another statement, so we're going to declare another statement here. It's going to be another float type. Result is going to be to Celsius. So we're going to call the function right here, and we're going to put our parameter as F value, Fahrenheit value. And then got another comment here, print the Fahrenheit value. And so we're going to use standard output to print to the terminal our Fahrenheit value. Even though, yes, we are converting this, but we're probably going to end up doing the same thing with Celsius. Just make sure I get that spelled right. If I'm not really paying attention to what I'm spelling, what I'm typing as far as the spelling is concerned, I'm more paying attention to the code. So my focus is more on the code than memorizing how to spell Fahrenheit. Then we're going to print again, which this time is going to be the Celsius, I believe. Yeah. So standard output, some text here, convert Fahrenheit to Celsius. And I'm going to jump down to the next line here. And put the result in. New line there. Okay. So like in the previous video and stuff, the first thing we do is first thing I do, discovering, learning how to do this, is I'm going to try to decipher the code first. So we got a function up here. It's a float type. The variable name, or it's called to Celsius. The parameter set is float Fahrenheit. Fahrenheit's the variable, float is the type. We're going to return the sum of whatever this is right here in this expression, putting in something for Fahrenheit to convert it from Fahrenheit to Celsius. So the first thing we're going to do, we need a value for Fahrenheit, which is going to be a float type. We're going to give it the F value for Fahrenheit value, so it's 98.8 degrees Fahrenheit currently, is what we're using as our example. Then next we are going to create another variable, float type, and it is going to be the result of Celsius with the argument F variable, which will be 98.8 right here. This will then get put into the Fahrenheit spot for the Fahrenheit variable. So 98.8 will get put here and then transferred down to here as well. And then our expression will have a result or a sum after the expression is done, which then we can bring back down in here into the main once it's finished up and then put it as our values. It won't go backwards like this, but it'll go forward. So whatever this is and stuff will have its own value to it, depending on what the return is. So when we output it, first thing we're going to do is we're going to output Fahrenheit, um, which is this variable right here. So this right here will be 98.8. And then we're going to output what it is after it's converted from Fahrenheit to Celsius, which will be the result, which is what we have the result down here. So we're going to get the original value and then the Celsius value in this case. So we're going to save it, run it, two outputs, what the Fahrenheit originally was, and then when it's converted over to Celsius. So 98.8, sorry, I got a fly bugging me right now. 98.8 Fahrenheit converted to Celsius is 37.11, etc. degrees. If you want to change some of these values, like currently the temperature here, where I am is actually 86 degrees. There's no decimal in there. Clear the terminal out. Save it right there, and so it's 86 degrees Fahrenheit here, Celsius. It's 30 degrees Celsius here. So simple enough, but that's how you would use a function and stuff to get you conversion. Now, do you have to use a function for this? No, not necessarily. You can rewrite the code in a different way and stuff to do that. If you wanted to maybe create an array or something like that and have when it's, say it's 30 degrees outside, it's this 30 degrees Fahrenheit outside, it's actually whatever in Celsius. If 32 degrees Fahrenheit, it's whatever Celsius. 40 degrees. If you wanted to create an array, you can do that and stuff. You probably have to get a little creative and stuff and figuring out how to get the array to work with the function, which we've already done that once before. In this case, I'm not going to do that. Um, this is you can completely play around with this all you want to try to do a bunch of different things. If you want to change this from, instead of converting Fahrenheit to Celsius, Celsius to Fahrenheit, if you knew what that formula was, you could put that in there in a different function and stuff and jump back and forth with it. Either way, there's a lot of different things you can do right here with this. There's a lot of different things you can do with functions, period. So but that's that for there. That's the example that they're showing. Let's go ahead and keep moving on. And that it seems to be the end of this little section inside of functions, which is function parameters. So now we're going to be moving on to function overloading. This section is got a little bit of content to it, so I think I will save that for another video. I don't want to be running more than half hour on a video. This is only 13 minutes long so far. I guess I can keep going with this and maybe get this whole section done in the next 17 to 20 minutes, whatnot. All right, let's see if we can do that. If it runs over a little bit, that's fine. C++ function overloading. So function overloading allows multiple functions to have the same name as long as their parameters are different in type or number. So we got an example right here. It's not really a runnable example though. Let me clear this code out right here real quick. Let's go and get rid of all this and all this right here. So what they're referring to in this is we're going to go ahead and copy this into the main right here. I don't know if we're going to be using the same example or not later on, but if there was a function called myFunction, with a type of integer, and you put into it an integer x. Okay, so I see what they're kind of doing here. Let's go ahead and get this example written down, and I can kind of explain it so I understand it a little bit better. I kind of understand it in my head, but I'm going to say it out loud, so I better understand it. So, and in a double, my function as it was stated in the content above this, we're not even going to end those because, I mean, this is not a program we're going to run. As it was stated right here, function overloading allows multiple functions to have the same name as long as their parameters are different. So what this is right here is this is like having, I know it's in the main, but ignore it here. In fact, I will move it to the outside of it just so it doesn't get too confusing right there. Okay. So this would be the same thing as having three different functions, all of them which have the same name. And that's what this is. We got three different functions here. One of them being an integer, one of them being a float, one of them being a double. Every one of them having the same name, but they take in different types of values. I think that's supposed to be an X after that, yes. Yes. Different types of values. Yes and no. So integer, in a sense, is an integral type. Float is the same thing. Float is a type of integral type. So integer, float, and double are all three an integral type. They have some sort of integer to them. Whether it's an integer that has a decimal point on it, long or short, or even no decimal point. And I may be saying it wrong, and that's what the comments are greatly there for. Um, I'm sure we'll get a better explanation of this in my other source that'll be much better said than what I'm saying it. But basically, it's the idea that you can create three different functions with three different types, all having the same variables or parameters in them. Well, not all having the same parameters because it does specifically say that you can use the um, multiple functions that have the same name but have different parameter types or numbers to them. So these have different types to them, but the same variables, except for this bottom one here. This bottom one has an extra one, extra variable with a double, which I'm pretty sure that the reason that they used an extra one with a double is because float and double are really close to being the same. They can be the same in the most part. In fact, a double can be an integer, a float can be an integer if they don't have a decimal point at the end of them. But now you can also do this and all have them all as integers as long as they have a different variable name, it sounds like. Or maybe if it was an integer with one, yeah, I think that's what it is. So different types, one, two, three different types. They added another one right here. This other one right here is because if you wanted a my function with just one integer, that's fine. If you wanted another my function with two integers, that makes it a different type of function, but it's what's called overloading because it's the same function with two values instead of one, sort of thing. Like I said, this is probably better explained in my other source than what it is here. But let's keep moving forward and see if it gets into better explanation of this and maybe even some examples. So I'm reading the content here. So this lets you use the same function name for similar tasks. Without function overloading, consider the following example, which have two functions that add numbers of different types. So now we have an example. So we can go ahead and clear this out right here so we can better understand what this is getting at. So I'll just basically type in this example here. So integer, the first one is going to be an integer type plus uh, func integer with parameters int x and int y. Return x plus y. And then we have another function down here, a double type function with plus func double. In this case, I don't see this. Let me go ahead and finish writing this, and I don't see this being really accurate for what they're talking about. Double x double y. Okay, now I do. Return x plus y. And then now we're going to go to the main and declare an integer with a variable my num1 is plus, this one's going to be this one right here with arguments 8 and 5. And then we got another one, I double my num2 with plus func double with a set of arguments of 4.3 and 6.26 in that, and then we're going to output standard output int is this, which is going to be set to my num1 with a new line after that in that, and then another standard output with the other variable. Double, and then my num2, and save that. Okay, so function overloading. The similar things to these two functions, even though they have different names and they have different types, they both carry the same value, an x, a y, an x and a y. Our two declarations right here, because we're trying to get a value for this variable and a value for this variable right here. So the first one right here is going to run into the integer one with x and with 8 and 5. So we are overloading both of these right here because both of them have the same variable names, x and y. The thing about it is they both have different function names to them, or function variables to them, function names to them. So I call them function names. I mean, there's a multiple different ways of saying this because it's a function name because this is a type, this is the variable. Variable is also known as the variable name. And then these are the parameters. Again, the type, the name. So this is a function right here, but this is the variable for the function, which is also the name of the function. Again, if I'm saying that wrong, feel free to correct me in the comments. That's perfectly fine. But what we are doing here is x and y, these can literally go into either one of them. But since they do actually have different names right here, they're not. They're going to go into two different functions, even though they have the same variable, x and y, but they're both set at two different types, with two different names, two different types, and two different returns. So in this case, we are going to just literally print out whatever 8 plus 5 is as an integer, and then whatever 4.3 is, or 4.3 plus 6.26 as a double. So we've saved it, we run the code, and we get our results of 13 and 10.56. Again, this is known as function overloading because we are overloading this right here part of it, the variables. We're using the same variables, different functions, different types. I don't know if they're going to do another example of that or not, but here is, I think this is going to be about the best way to explain in another sense, because this is the type difference. There is also a number difference. So what if we change this to integer as well? We gave this the same name as the previous one, int. So they both have the exact same name to them. Now let's change the types in these to int as well. Int as well. But instead of having two different ones, this second one's only going to have one. So we're going to remove that one right there. I think this is the number difference. Where this one has 2, this one only has 1. This one we're going to end up returning just x. Actually, you know what? We'll do x plus 2. So now we need to change this right here because we're not going to have a double type anymore. We're going to have an integer type now. We're going to change this one right here to the same thing, the integer function. We're going to get rid of the decimal points on this one and this one. We got two functions that are identical to each other. The only difference is the amount of variables inside of them. So the first one's still going to go to the first one, but this one right here, we're going to go ahead and remove this one right here. This is another way of function overloading that I know of. So now we're going to go ahead and change this one right here. Int function 1 parameter, int function 2 parameter. And I think that's where the number difference comes in play. And then go ahead and save this and run this. And yes. So function overloading, same name, same types, but one parameter here, 2 parameters there. So, I mean, everything's identical. The only difference is the amount of arguments and the amount of parameters, which is what's known as function overloading, I believe. It's the best I'm getting out of it. So you can either change the type by changing the integer on both sides, or you can change how many parameters and how many arguments. But you're getting the same function both ways. You're doing the same thing. In the first one and stuff, we were still adding 2 variables together. So we get 13 to 6. Now, again, if we put another variable in this, right here, then it would both use this top function right there. With only one, we're only using the bottom one. So I hope that makes sense. That's kind of how I understood it. At least I understand it now. I may have not have understood it before, but that's how I understand it now. So, but again, this example and stuff was without function overloading. I should have repeated that right there part. I just now seen that without function overloading. So that previous example was not function overloading. The problem, we had to create 2 different function names for the same logic. We have had to create 2 different function names for the same logic. Okay, so they had to create 2 different names for the same logic of what it was doing. I don't understand that. Maybe somebody else does. Using function overloading, I'm guessing this is where instead of defining 2 different function names, so they are setting 2 different function names. They're still using 2 different types. Okay, so they're stating that to do this one right here, the first example that we had, they end up having to give it 2 different names. Because of the fact of how, so if we had kept this, here's what would happen. So double, we'll change this back to double as well. I see what they're saying with that. The comment right here, problem, we had to create 2 different function names for the same logic. That right there, to understand what that is getting at. Double 4.25 7.15. Okay, and then we're going to go ahead and change this back to double as well. And I had to use 2 different names. Okay, so actually let's go ahead and keep this the same name, int, and to show what the problem would be to have this set up this way. And we'll go ahead and keep this the same way as well. Int y. Okay. Actually, no. We'll use the same name for both of them, but we'll change the types. Double, double, double. Okay. So there is, if I save this right here like this, there is a problem with this. Okay. They're stating that if they had used the same names, you would run into an issue with this because of the way something that we haven't discovered yet. Um, and it's something that you'll find out later on because it's a detail they do not mention in their source. They may mention it later on, but they have not mentioned it yet. So anytime you try to pass a double into an integer, what happens since an integer cannot take in a decimal is simply in this form right here with the parentheses, the 0.25 ends up dropping off. The 0.15 ends up dropping off. So this right here doesn't end up coming to this right here, even though they're both doubles. This function actually does not get used at all, if I'm not mistaken. I believe this function is the only function that ends up getting used both times. And it just drops off the 0.25 and 0.15. If I am correct on that, then we're going to end up with two different results. The first one's going to be the 13. The second one is going to be 11 without a decimal point because it's going to end up using this one both times. We're going to go ahead and change this right here to y. Actually, we're going to adjust this to y plus 1. No, plus 10 to show a difference. Save. So if this function right here was to get used at all, it would have 10 more added to it. But it doesn't. Only this function gets used, period, I believe, if I'm not mistaken. So we're going to end up with 13 and 11. If this one got used, it would end up being 13 and 21. We got it saved. Let's run. Let's see what happens. I'm pretty sure only the top function will get used. Oh, no, it actually saved the decimal. Oh, because I got those right there and there. No, it's because of this right here. I have all of it right there, but still, and it still did use that. Wow. I don't get what this whole thing is about then. Problem, we had to create two different function names for the same logic. Why? It didn't do what I was expecting it to do. It went ahead and used, let's see. Yeah, it went ahead and used this one right here instead of that one right there. And I figured it would have used this one right here. What if I had changed this right here to int instead? Control save, run it again. It drops it off, but it still uses the second one. Interesting. Okay, well, until I get to a section of stuff that can kind of explain this better, because obviously I've forgotten how that works. This one is using the first function, where this one right here is using the second function. I figured they both would have used the first function, not the second one at all. They both have the same name to them. But obviously the first one's using the first one, otherwise it would be incremented, or there would be another 10 right there, so it would be actually 23, not 13. And the second one, when I had double right here, it used the second one because it added 10 more to it. It would be 11, but actually it makes it 22 because of this right here. So this may be, I'm going to actually, my best guess on this is that since there are changes coming to C++ this year right now, and you may have noticed it and stuff with all the massive updates that's been going on. Uh, so every 3 years, C++ gets updated, and there's going to be the reference for the CPP reference guide is going to probably be changed a little bit by the end of the year. which means the code has been changed, C++ code has been changed, and compilers will be changed for whatever the code changes to. At the end of this year, all those changes should be finalized. And this right here could be just a little out of date to what this is. Either that or else I'm not reading this right. We had to create two different function names for the same logic, and I don't understand that. I am doing it just the same way, and it's coming out just fine. Double right here, and it's still using, the first one right here is using the first function. The second one is using the second function. That's why I added the additional 10 right here to indicate which function it's actually using. So, it may be a new change, and the material right here on the website has not been updated for the new changes yet, which they probably won't be updated until after the end of the year, because there's no point in changing it and changing it and changing it every time they update C++ and compilers with the new information, which is, like I said, why it's a good time right now to be learning, because by the end of the year, once you get all this learned, you keep going through it and you figure out new stuff, you're going to also kind of be questioning things, but then you're going to be kind of saying, okay, well, maybe it's the changes. So when the new year comes, it may only take you a month to 3 months to understand all the new changes that have happened in C++. And then you shouldn't have to worry about it too much more for the next 3 years after that until they start doing another update on C++. I knew I'd run into a long thing right here with this, but anyways, I didn't expect to run into something like this. Either way, let's keep moving forward. Just, I've learned something right here. I've discovered something new right here. I don't really understand this phrase right here, but it's the whole idea of function overloading. And this first example was supposed to be function without function overloading, where the second example is with function overloading. And the only thing we're doing different, we've already got the same names like they have in their example. I've added 10 to show that whether this one is being used or not. They still got everything set up the same way in their example as I do in mine, and they are running it the same way. So my example and their example, let's see what their output comes out to be. So their output is 13 and 10.56. I'm not using the same exact numbers that they are, but I believe that's what we got too. In the second example, they get 13 and 10.6 with the same function name again. Let me go ahead and adjust this and see if this, I know I won't, yeah, I won't have to. Because I'm getting the same result either way, with the same function name or without the same function name. The types are different. The numbers aren't. We've already discussed that the numbers and the type differences both ways. So again, I don't understand that phrase that they use. Using function overloading instead of defining two functions that should do the same thing, it is better to use overload. Better to overload one. It is better to overload one instead of defining two functions, which we got two functions here, just like in their example, that should do the same thing. It is better to overload one. In the example below, we overload the plus function, same name, to work for both integer and double. Okay, so one function name to work for both. In the previous one without the overloading and stuff, like I said, I'm not going to be able to figure that one out. Note, multiple functions can have the same name as long as the number or type of parameter are different. And we've already shown that. We got type difference right here. In the previous example, we had a number difference in the parameter and so forth, so on. We already demonstrated that. So function overloading by number or parentheses, and we've already shown that right there. So they use basically 2 right here. I used 1 right here, but they're going to use 3, but they're going to do the same thing. Is what we did. Basically have, sorry, basically they're going to just have a parameter difference and an argument difference. Everything's going to be set up exactly the same. Not as same as what this, but the same as what we had before, where we had two functions that had the same name, same type. The only difference is we had 2 right here and only 1 right here and a little bit ago. Their example is showing 3 on this one instead of just 1. Pretty much having the same output. So if you, yeah. But yeah, I do not get this part right here without function overloading to where they're changing the name. Maybe that is showing just an example of 2 different functions with 2 different names. And the call to those functions, it's specifically situating. Again, this example right here, this section, I do not understand. I know that they're using 2 different functions. I know they're using 2 different names for functions. Basically, everything is completely different. They're calling 2 different functions altogether. Um, but they're stating that there was a problem. We had to create 2 different function names for the same logic. So, anyways, moving on. Like I said, if we get stuck on something and we just start spinning our wheels trying to figure it out, and it's better just to move on and see if it comes back later on for us to better understand it, and hopefully it'll come back later on in the next source we use. But going over it and over it and over it, me understanding what they're talking about is one thing. Me understanding the actual language is a completely different thing. I don't understand what a lot of people say a lot of times. So, anyways, moving on. So I think we're going to go and cut this video off right there. That's actually long enough on this video. When we come back, we will start discussing C++ variable scope. We are still in the functions category right now for W3 schools and C++. So this is what we'll come back to pick up on in the next video. For now, if you want to mess around with this, feel free to. If you need to leave a comment correcting something I've said, or maybe even help me understand it or help anybody else understand it, that's perfectly fine. If you like the videos, click the like button. If you have any questions or comments, also, you can just throw those in there. It doesn't bother me one bit. Again, I'm not really doing this so much for myself or for anybody else. I'm just sharing. Kind of reminds me of the whole sharing is caring thing. So maybe if you need some inspiration and helping to write something, or maybe if you need a reminder on something, you can see it this way, and it might remind you of something or help improve your code writing. I don't know, or teach you something new about code. That's perfectly fine, but it is what it is. So, like I said, next video will pick up right here, and I think that'll be it for this video. Hope you enjoyed it, and I'll see you next time.